Welcome back to Backspace Academy. In this lecture on AWS CloudWatch, we'll start off by building on what we already know about what CloudWatch is, and then we'll have a look at CloudWatch alarms and how we can implement these and use these to trigger corrective action. Then we'll move on CloudWatch logs and how we can use these to store data from our CloudWatch metrics and also analyze that data as well. And finally, we'll look at some use cases of how we might implement AWS CloudWatch. CloudWatch, it's a monitoring and observability service. It allows you to collect logs, metrics, and custom metrics of your AWS resources. You can monitor metrics, statistics of those metrics, and also alarms in custom dashboards. You can act on alarms and events and then implement corrective action in the event that there is a problem. You can analyze those metrics and logs with CloudWatch Log Insights. And it has high compliance and security because access is controlled with IAM and the data is also encrypted at rest and in transit. CloudWatch metrics are data that we define or AWS can define for us about the performance of our systems. They are available in most AWS services, but they're not available in all regions. Some of these services include Billing, DynamoDB, EC2, EBS, Elastic Beanstalk, OpsWorks, Kinesis Firehose. Now that's not a complete list. To get the full list, it will be defined in the developer guide, and there is a URL for that, and it changes quite regularly as new services are added to AWS. There are many AWS managed CloudWatch metrics, but you can also create your own custom metrics. To publish your own custom metrics to CloudWatch, you can do that using the AWS command line interface or using one of the many software development kits to communicate and send those metrics to the CloudWatch service. There are two options for resolution. You have the standard resolution, which is a 1 minute granularity. So samples will be taken every minute. And you have high resolution, which will be 1 second granularity. Metrics that are automatically produced by AWS services are standard resolution by default. CloudWatch alarms can alert us when a metric exceeds a threshold level that we define. We can have billing alarms that can alert us when our bill exceeds a certain level. We could also have resource alarms. For example, we could have an auto-scaling group of EC2 instances, and they could be expanded and contracted based upon a billing alarm of the utilization of those resources. It integrates with Amazon SNS to send notifications and emails. It consists of 3 states: OK, and then alarm if the metric has exceeded a threshold level, and insufficient data. For example, you may have a CloudWatch metric that is monitored every 10 minutes. So for the first 10 minutes, there will be no data for that CloudWatch alarm. So the alarm will show insufficient data until it gets that data coming in. When you create an alarm, you define an alarm threshold and an alarm evaluation period. If a CloudWatch metric is above the alarm threshold for the number of time periods that you have defined by that evaluation period, then the alarm is invoked. If we have a look at the diagram here, we can see that an alarm threshold has been set to 3 and the evaluation period has also been set to 3. The first time there that the value has exceeded the threshold level, it has done that for at least 3 periods, and so that alarm has been triggered. The second time that it exceeds that threshold value, it only did it for 1 period, and so there is no action. There is no alarm or any corrective action that has been invoked. CloudWatch logs allows us to store the values of our metrics as a series of logs in a CloudWatch logs file. To use CloudWatch logs, you need to have the CloudWatch logs agent installed on the instance that you are monitoring. And that will allow you to monitor and store those logs and also access those log files readily of your EC2 instances, of your CloudTrail activity, and other sources that are compatible with CloudWatch logs. Your CloudWatch logs can be searched and analyzed quite easily using CloudWatch Log Insights. So you may recognize this diagram from our Elastic Beanstalk lab, but what we're going to do is have a look at how CloudWatch was working in the background here. So we had this auto scaling group that was adding and terminating instances based on the CPU load of those EC2 instances. Now what was happening is that the EC2 instances were sending metrics of their CPU utilization back to the CloudWatch service. And then the CloudWatch service was monitoring that as a metric. And it had an alarm set up that if the CPU utilization exceeded a certain threshold, then that would trigger an event. And that event was to add instances to an auto-scaling group. And again, if the threshold went below that CPU utilization, for example, if it went down to 25%, then the auto-scaling group would be triggered by that CloudWatch alarm, and the auto-scaling group would terminate instances. Here is another architecture diagram that we have seen before in our Introduction to AWS lectures, and that is for decoupling applications using Amazon SQS. So on the left-hand side there, we can see that messages are coming in for processing, and those messages will be processed by an EC2 instance. So it could be a message to process an image and to do some filtering on an image or change the size of an image or something like that. So those messages are going to come in with that information for that job, and they are going to build up in an SQS queue. So if a big burst of messages come in, then our EC2 instances will not be overloaded. But what happens if our EC2 instances just cannot keep up with the average of those incoming messages, and that SQS queue continues to grow and grow and grow until it becomes too large, and then messages are no longer going to the queue because it's full? What we can do is that we can implement a CloudWatch alarm, and that CloudWatch alarm will monitor the queue length metric of that SQS queue. And if the queue length gets beyond a certain length, we have two alarms there, or two thresholds. The highest threshold is that the SQS queue is just out of control and it's huge. Then we could send an SNS email notification to an administrator to investigate what is going on. But we also have another threshold level, which will be a lower threshold level, and that will trigger an EC2 auto-scaling event. And so what will happen is that the EC2 auto-scaling group will expand by adding instances if the queue length exceeds that threshold. And if the queue length goes below a minimum threshold, then it will terminate those instances. And this way we can manage very large spikes in demand, and at the same time we're not going to be losing any of those incoming messages. Every job will get done. So that brings us to the end of our discussion on CloudWatch. I hope you got a lot out of it, and I look forward to seeing you in the next one.